This is Euclid Book 5, proposition number 20. I know you see two sets of lines here. We're only going to cover the first set. And let's see. If there be three magnitudes, well, obviously there are three magnitudes. 1, 2, 3. Okay, and there are actually three more magnitudes right here, 4, 5, and 6. But we're going to concentrate on the first three. It says if there be three magnitudes and others equal to them in multitude, okay, which taken 2 and 2 are in the same ratio, and if x equali, the first be greater than the third, and the fourth be also greater than the sixth, and so on and so forth. And I can go on and read the whole dang thing, but believe me, you don't want to hear it. Okay, let there be three magnitudes, A, B, and C. Well, there's A, B, and C right there. And others, D, E, and F. D, E, and F. And they're equal to them in multitude. Okay? Now, this is 1.5. This is 3. So, there are two of these in here. This is a quarter, this is a half. There are two of these in here. Here we have a 1-inch line and we have a 2-inch line. So there are two of these in here. Okay? That's very important. Which taken 2 and 2 are in the same ratio, so that as A is to B, okay, so is D is to E. Okay? The same ratio A is to B is also D is to E. And as B is to C, so is E is to F. So these two and these two lines are in the same ratio, and these two lines and these two lines are in the same ratio. And let A be greater than C. A is greater than C. Okay? We're going to prove that D is greater than F. We're going to prove that D is greater than F. Now, if A is greater than C, well, obviously, if A is greater than C, well, A is greater than C. And B is some other magnitude, and the greater has to the same a greater ratio than the less has. Okay, so A has to be a greater ratio than C has to be. And we can say this by Euclid Book 5, proposition number 8. Okay. But as A is to B, so as D is to E. Okay? So this is in the same ratio as this. And as C is to B inversely, and we'll get into that in just a second, as C is to B, so as F is to E. So as F is to E. So these two are in the same ratio, these two are in the same ratio, and inversely, these are in the same ratio, and these are in the same ratio. So whether you say C is to B or B is to C, if you say C is to B as F is to E, then fine. If you say B is to C as E is to F, you can say fine. Same difference. Okay? Therefore, D also has to E a greater ratio than F has to E. D has to E a greater ratio than F has to E. And this is proved by Euclid Book 5, proposition number 13. But of magnitudes which have a ratio to the same, that which has a greater ratio is greater. That is Euclid Book 5, proposition 10. Therefore, D is greater than F. D is greater than F. And we could go on proving that they're equal and they're less, so on and so forth if we wanted to, but I'm going to let you go ahead and prove that for yourself. I will tell you more in a future video. Stay tuned.